my name is Spaur. I introduced myself already. I'm going to go over the Aerial and Aquatic Research team and essentially a little bit about history of remotely piloted systems and what we've done research-wise and kind of how this stuff can be applied. So I'm going to do a quick overview of kind of everything. They're going to go way more into detail. I'm going to try not to get too far into it, but we're just kind of brush about the capabilities of these systems and essentially how we've used them in the field already.
So I'll just start out saying that is our CSUCI class we took to the Cook Islands this summer.
So yeah, that's, oh, you can recognize me. And you can recognize that right there. So this is actually the Cook Islands, picturesque, beautiful, remote Pacific island. A lot of interesting ecological challenges going on there. So we're doing a lot of mapping, looking for fresh water sources, examining the agriculture that's there, looking at a lot of different watersheds, and just generally getting a lot of different data, both in the air, but also underwater, where we did a little bit of the research with coral that I was talking about earlier. And so I'll get into that a little bit more in the later slides. So remotely piloted systems. So essentially what these are, they're systems that you control remotely. There's something you're not actually in. And with these systems, they're not always radio controlled or directly controlled. Sometimes they're autonomous, meaning they pilot themselves, but you also have control in the fact that you can say, okay, I want you to stay in this area, and it'll stay in that area. Or I want you to fly in circles over here, and it'll fly in the circles. There's some sort of control, even though it may not be direct control. And these systems are in the air, they're on the ground, they're on the surface of the ocean, and they're under the surface of the ocean. And if you look around this room, there's actually kind of a little bit of everything. We have airplanes there. Inside the locked up cabinets, we have helicopter type units. Then we have, there's an autonomous boat that's being built right over there. Those guys back there are submarines. So there's a lot of different kinds, a lot of different flavors of remotely piloted systems. And so we're going to kind of brush across all of them, but we're mostly going to focus on aerial stuff here for this class. So a little bit of the history on this sort of thing. Essentially there's two main things for remotely piloted systems as far as the originators. So one of the things they were having issues with, and back in, was it
19th century?
Yeah, 19th century. They're basically just getting to the age where they have cameras that are reliable. And then they realized, well, we have kites. So these are something we can hold on to, we can fly, we can move around. Well, why don't we put a camera on that kite? And so they were actually using this to do field reconnaissance for the military. So they're basically doing what we're doing now with drones. You put a camera on it, you fly it, you get pictures of what you're interested in. Next was Nikolai Tesla. He actually created the first remote control vehicle that was controlled with radio waves. And that was a radio controlled boat, which is what you see here. And it was actually made in 1898, so quite a while ago. And it's actually quite amazing how long these systems have been in use. So here in the 19th century, you have the first known remotely piloted systems. And basically, one common factor that is in all of the remotely piloted systems is that there's been some influence, or the main driver being the military. Combat reconnaissance using that kite. They, in the 1950s, started developing the submarines, and they actually used submarines to recover atomic bombs that didn't go off. And so a lot of this stuff has been associated with the military, and because of that, there's a lot of nomenclature, a lot of acronyms and that sort of thing that come from the military. So this is actually in Vietnam. So this was an autonomous jet that was in Vietnam. So you think about drones, they've been around for a while, but it wasn't until you had the Predator, which is the big scary flying in Iraq, blowing up everybody, drones, that people really caught on large scale to what's been in development. And so, like I was saying, the military, they absolutely love acronyms. All public services love acronyms.
Is that right, Casey?
What's up?
Is that right, Casey?
Corey.
Corey, sorry,
Yes.
Corey.
Yes, it's acronym everything. Acronym everything. I'll try to be loud. So we have UAV, unmanned aerial vehicle. UAS, unmanned aerial system. So there's a lot of differing opinions as to what things should be called. And so sometimes they're a little bit redundant. And And so when you get to the aerial stuff, you have RW, which is rotor wing, which is the helicopters. You have fixed wing, which is your airplane like that one up there. You have aquatic ones, which are USV, unmanned surface vehicle, which is what that boat back there would be considered. Autonomous surface vehicle, which is one that's kind of able to pilot itself. ROV, which is a remotely operated vehicle, which is confusing because, I mean, technically any of these could be a remotely operated vehicle. And then we have AUV, and it's an autonomous underwater vehicle. And then the UUV, which is an unmanned underwater vehicle. And there's actually much more than just these. And so for the purpose of this class, we have this overarching acronym just to make it even worse that we call RPS, which is remotely piloted systems. So that just kind of encompasses everything quite nicely. And then to make things even more confusing, they're all robotics, and they're all what people consider to be drones. So that brings me to the next part. What is a drone? And this is going to be punched and talked about on quite a bit more. But the perception of what a drone is, everybody has differing opinions. You know, is it a worker bee drone? Is it the scary thing that flies over to the Middle East? Is it the little Hubsan or the little quadcopter that you got for Christmas? There's a lot of different definitions of what they are, and so we'll touch on that quite a bit more, especially when we get into the survey where we actually do public opinion as to what these systems are. But so essentially, there's something that you control remotely somehow, remotely piloted system. So these are some of the applications that these systems have. There's quite a bit, and this is actually just the tip of the iceberg. It goes way further than this. And so we're talking about it from the environmental science perspective because that's what we're the environmental science department. However, that's not all the interest that we have in it. There's so many things you can do. You can do professional photography. You can do landscape monitoring. You can do environmental research. You can do climate change research. You can do basic research on like chemistry and different effects that the different things like pollution have on the atmosphere. You can look at aviation research, developing new platforms. You can look at all these things. There's just tons and tons of applications. And there's also lots of applications in things like performing arts. There's a video that I'm sure Sean will show later, which shows kind of some of the choreographed performance art that people have done with drones. And they've done things like make huge cityscape light shows with drones up in the air. So there's absolutely so many different things. And that's also underwater as well. There's a lot of different applications underwater, like with exploration as well. So,
and I would just say on that, a quick side note, if that is of interest to you guys, we are partnering with the Performing Arts Department this semester. There's a thing, if you're new to campus, you might not know, we have at the end of the spring, we have a thing called Arts Under the Stars. And it's typically musicians and dancers and actors and all that kind of good stuff. This year, for the first time, we're going to do some kind of drone thing. So unclear what that is. We're partnering with the students from Performing Arts, and they're designing it, and we're sort of building / piloting it. So hopefully, though, it's a much more interactive process. So that's another opportunity. It's not research, quote unquote, but it certainly is using these tools. And so in the next week or two, once their class gets settled down, our class gets settled down, hopefully we'll do some exchanges. So if that's of interest to you guys as well, I need at least a few students to be partnered with that, both to tweak the platforms to do the whatever art, maybe LED lights or something like that, and then in early May to actually that one night to actually fly them. So I think that's another cool thing. Sorry.
No. So yeah, there's all these different things, and so if you're interested in these particular topics, there's lots of information out there, and the team, like I'll talk about more, is working on quite a few of these. So I'm going to kind of brush over some of the platforms that you guys will be exposed to in this course. I'm not going to talk to you exactly about how each individual one works because I'll be sitting here and talking forever. And I'm already going to be up here talking forever with all this stuff I'm trying to smash in these 30 minutes. But this is a Phantom, if you guys recognize this. No? So this is by a company called DJI. They're one of the largest commercial drone manufacturers that's out there. This is kind of like the iPhone of drones or quadcopters. So this is a buy it off the shelf. The newer ones are all ready to go. You don't have to put a whole lot of stuff together, make stuff talk to each other. and it has a lot of autopilot functions, which essentially make it really easy to fly. And so you guys are going to be learning kind of the more manual way of flying, because if you can learn manual, when you go to the autonomous or the assisted type of flying that these things do, it's going to be so easy. You're going to be like, why didn't I do this in the beginning? But the real reason is because you need to know how to fly things or operate things in the worst conditions, and you need to know if there's an equipment failure, how to properly get it back safely. And so, so this is it's about, what is it, Todd? About $1,000 nowadays? $700.
Yeah, there's
With the camera, yeah.
models,
Yeah, there's a ton of different models, but like a base model, I'd say
between like $700 and $1,300.
Yeah, and so these guys have pretty good quality of camera. They can shoot up to 4K video, and they have some limitations, but this is your pretty much your entry level, entry level at the higher professional part. So this is the one that's going to have GPS unit on it, autopilot functions, a nice camera, but this is kind of the lower end of the spectrum. They get a lot more expensive and a lot bigger if you want to do high quality video and that sort of thing.
So this is like, if you guys know anything about cameras, this is like a prosumer kind of category. So it's not the cheap thing that you just get, but yet it's not the kind of thing maybe that a dedicated pure professional would use, but it's that sort of step in between.
Yeah, it's not your $50 Amazon one that you crash it and you're like, oh well, I'll just get another one, or I'll just put it down and walk away. This is the, man, I invested a lot of money. Why did I break this so bad? So this gets to the level where you want to be careful, but there's people, and we know this from even the Cook Islands. We met a guy who had one flying it over the ocean. Second day he's owned it, no training whatsoever, just jamming fast. And I see people fly these with lots of experience, and we go, hey, have you been flying these for a long time? It's like, no, I just got this thing. It's awesome. And he's like flying it almost like further than he can see.
In the path of a runway.
Yeah.
As well.
Sometimes. So these have the potential to be really dangerous, but we're going to teach you how to not be that guy, hopefully.
Kiwis.
And so this is kind of the next step up. This is the Inspire. So Todd has a Phantom. You still have a Phantom?
Yeah, we got a couple.
Okay. So so we have that, and this is the kind of our mainstay for our research that we're going to be doing. This is the higher quality camera with a really nice gimbal, meaning that really stabilized images, and it's got these arms here, which actually go from a down position. So when you land, the arms are down here, and then when you take off, they actually will go up. So you have a full 360-degree view that's unobstructed. And so with these really high quality camera, really stabilized, these also have a lot of really awesome measures to keep it really stable in the air. So you can have this thing, and it could be a 20-knot wind, and it could do a pretty good job of keeping itself still. Likewise, if it's still air, you could take it and hold it, walk over here, let it go, and it'll go back to where it was. So a bunch of really cool features. But this is something hopefully that you guys, you definitely will be able to fly towards the end of this program. So this is the big brother, and this is the spreading wings. These are all the same company, by the way, DJI. This is the spreading wings. This is an octocopter, so 8 rotors. This is a heavy lift one. So this is the one where you can carry SLR camera, so professional type camera. And I don't know if we're going to have the opportunity, but hopefully we'll have the opportunity to see one of these in person. But I don't think that we're going to be able to get you guys some flight time on this. But these things average roughly about 10 grand when they're all properly set up. And the batteries are like...
I could bring some.
Okay, cool.
If they want to see it.
Yeah, it's.
Yeah, I think one day we'll just bring in stuff just to show you guys the range. We won't be able to fly all this stuff unless Todd wants us to crash his super cheap stuff. But
super cheap.
But at least you guys will be able to see this stuff.
It only costs as much as your car, so don't worry about it.
Right. Unless you have a really crappy car, then it costs more than your car.
Well, it costs about 4 of my cars. So this is one of our main trainers. This is called the Blade, 180QX. So this is made by Blade, and we have about 3 of these guys, and so they're going to be mostly our main trainers. They don't have GPS. They do have stabilization, but it's not like the Inspire or the Phantom.
Explain briefly what that is.
Sure. And so with the stabilization is kind of what I'm talking about, where it stabilizes itself. But so with these units, they have essentially sensors like your phone does. So you have Google Glass, or you have some like a 3D video, and you move your phone, and it's able to change what you're seeing, like in a 360 video. Or there's the app where you can like look at the stars, and it'll tell you what constellation you're looking at. That has accelerometers in your phone. And so what that means is it's able, accelerometers and gyros. And what that means is it's able to know its orientation. So if you're holding your phone like this, your phone knows it. And essentially they're just little sensors that are inside your cell phone. These have them inside the flight controller as well. And so it knows what flat is, essentially. And when you turn it on, it kind of says, okay, this is flat. And then when you fly it, if you give it some input to the right and then you let go, it's going to go back to flat. Whereas an unstabilized one, if you put it to the right, it would just keep going to the right. And
until you correct it.
Until you
with
correct it,
other
yeah.
input, yeah.
And so these have the basic style, which will level itself, but it doesn't know its GPS location. It doesn't know how high up off the ground it is. So it's sophisticated in that it can help stabilize your flight. But the previous ones actually have things like a sonar, where it can know how high off the ground it is. It's got a photo sensor where it can actually look at the ground, kind of like we would with our eyes, and it'll look and it'll see how the ground is moving. And because of that, it'll know which direction it's heading. And then also it's got the GPS. So the previous models have lots of things to keep it very stable. These have some. And so these are good trainers because, it gets you to not rely on having all those extra benefits in case your GPS unit goes out and you're not able to keep it in one place, or your sonar goes out and it doesn't know how high it is. And so, a lot of these little quads, like the Hubsan, which we have one of. I don't think I have a slide for it actually, but it was that little tiny one in the what are drones?
We have the one I just got two, so we have two basically.
Okay, so we have two basically. That has the same thing. It's just a lot smaller. But these are great trainers because they're really light, they're really durable, and you crash them, you might have to put on some new propellers. Keep going. Go to this one.
We can fly those inside.
Yeah, you can fly those inside.
Yeah.
They don't look very big.
Yeah.
No, they're about this big.
And the Hubsan he's talking about is your palm
Yeah,
size.
the
so it's even
Hubsan's like this big. So they're really small. This is another one called the Iris. This is made by a company called 3D Robotics. This one is more akin to the Phantom. It has its own benefits and its own downfalls. DJI and 3D Robotics are pretty big competitors, so all of their models are pretty comparable. So this is more of this has a GoPro on it here, but it has this stabilization rig right here. So it's going to be much like the Inspire or the Phantom, where if you're flying, it's going to keep your camera straight, just like this. And so this has a bunch of pretty interesting benefits because with and this has changed in recent years, but DJI used to be kind of like the iPhone of drones, and then 3D Robotics used to be like the Android of drones. So essentially, before 3D Robotics was a little bit more open with the source. So essentially, what that means is that anybody can edit the programming for these drones. The DJI was a little bit more closed, but recently they just opened stuff up to where you can have third-party programmers come in and add stuff. And so a lot of the mapping that we do is those third-party programs that I was just talking about. So they have apps which control the drone, give it essentially places to go, and tell it where to take pictures. So in past, these things were a little bit better for having the third-party apps, but things are kind of changing. One thing that this does have is this has a flight controller, which is called a Pixhawk. And a flight controller is essentially the brains that control the motors. They take the sensor data, they do the stabilization. And the Pixhawk that's inside this, you can actually take out of that craft and put it in that one, and then tell it that it's an airplane now instead of a quadcopter, and it will adapt and be able to fly that on autopilot. It takes some learning, machine learning, meaning that you have to fly it, and it has to understand how things work, like the aerodynamics and that sort of thing. But it's a very versatile flight controller, whereas you can't do that with the DJI products.
FAA can't handle that.
Yeah.
The FAA wants us to report everything based on as if it was an airplane. So they want like a unique identifier number, like a serial number, an N number. But it sort of breaks the whole process when we can put the thing inside that fixed wing and make it an airplane, or put it inside one of these guys. One of our colleagues just printed, or a few months ago, printed on a 3D printer on a ship offshore on a Navy vessel, essentially the superstructure for the quadcopter here, and put a Pixhawk brain in it and flew it around. So when you can do that kind of stuff, it's great for us. It gives us more flexibility. And this control of this brain thing, it's not tens of thousands of dollars. It's like $200.
Yep.
So it gives us tremendous flexibility. So generally it's great for us, even though it causes the regulators some headaches.
Yeah, and just to speak to what the flexibility of that system is, there's going to be one inside that boat. So that means that this thing can control a boat. It can control a land vehicle with wheels. It can control an airplane, a quadcopter, an octocopter. So very versatile and robust system that they have. So this is the snowy plover, which I built with the help of the fine research students that are in here. This is right there, and essentially it's a commercially available fixed wing aircraft. So this is a Sky Hunter platform, which is essentially just a really big foam airplane, which is made for FPV. FPV is first person view, and that's what this camera is right here. So there's two cameras. There's actually three cameras on this aircraft. There's a GoPro, which is kind of like the ride-along high quality. So it shoots 4K. I keep saying 4K. 4K is, most new TVs can go to 4K, but not always. As far as they're not able to go that high most of the time, unless you specifically buy a TV that's 4K or higher resolution. So it's really high resolution.
The density of pixels.
The density of pixels. And it's to the point where if you have an older computer, you can't even watch the raw video, because that's how large the files and how much information it takes to have the detail that's in this video. So it's really high quality. But the camera over here on the left, which is the FPV camera, is more of an analog camera that has a lower quality, but you can put on a pair of goggles and you can see what the aircraft sees. And with these flight controllers, they have all the sensor data. They have the gyro, accelerometer, and they have things like this little tube right here, which is airspeed sensor. So this is all this data which is being collected. And in the flight controller, you can put it on a module called an OSD, which is an on-screen display, and it'll actually show you that. It'll show it. It's kind of like playing a video game where you see that horizontal azimuth, that artificial horizon. You'll have wind speed data, you'll have altitude, you'll have GPS location, tons of information. It puts it over the image that you'll see with your goggles on. So it's really cool for when you're flying, because it opens up a lot of doors. Because if you're just standing here watching up there, it's kind of difficult to survey a particular spot. But then again, that's why you're going to be using your autonomous functions. And there is some issues with that with the FAA currently, and they're working on rules as far as when you can do it, when you can't do it. Do you need a spotter? Do you not need a spotter? And so that stuff's kind of there's a lot of things that are in the works as far as policy is concerned with these systems.
And I would say, with regards to that, we're going to teach you guys a super solid way to do this stuff. We'll show you probably in some cases a bit overkill in terms of safety and all this and that, but that's how we operate. And so our standard is higher than, I mean, there is no real standard now, but our expectation is much higher than Joe Blow, so that when the FAA does come out with these standards, we think our standards will at least be equivalent, if not probably exceed them. So when you talk about later on getting a job or whatever, you'll know how you'll be way safer, way more responsible, way more whatever. So whenever the regulatory agencies ask questions, well, have you? Yep. Well, yeah, but I don't. Yep. You know, so we're ahead of the curve, and we want to be more responsible, because we don't want to be that joker that causes a problem and draws negative attention, or God forbid causes an accident or something like that, right? So we go over and above what just the Joe Blow, hobbyists, or for that matter, even Joe Blow real estate agent that's flying this to get images, thinks is safe.
And then one other thing I would say is, Paul's going into some detail about these airplanes and stuff. That you're going to get a lot
You're
more.
gonna get a lot
It's not. He's just kind of throwing it at you. You don't understand it all. It doesn't make sense. You will later, so don't worry about it.
Yeah, I'm trying to give an encompassing view without trying to go into too much detail, and these guys will elaborate on all these things that we're talking about.
And I would say that I think the key thing is for you guys, as you're just starting to put your toe in the water here, is this thing, that thing on the wall, this thing in the screen here. It's $1,500, give or take a little bit. If we were really wealthy, we could have built it for like $2,500 or $3,000. It's effectively quite similar to units that cost like $200,000 that you would buy off the shelf.
Or a full-scale airplane.
Or a full-scale airplane, right? Yeah, for mapping, for data collection, absolutely equivalent. In many cases, equivalent to an airplane. And so, I mean, we'll talk about this later, but just real quick, the unit that we're going to attack, well, I don't know where it went, but the Inspire, the guy that has its arms rock up, that plus this new LiDAR thing we're putting on is maybe going to be 10, 12K-ish when we're done. And then we have that to do millimeter level mapping of this building, of an electrical tower if we need it, of an animal's den, of an eroding cliff side. And that's it. And we can do it now, and then you can go do it for your capstone, and then Casey can use it, and then Todd, and we just over and over and over and over again. To do one relatively small site, when we contracted last year, we had a National Science Foundation grant to look at some erosion, just to do one site. And all that was then to give us data from one flight, $30,000. So this is 1/3 the price, and that we're just building together, right? Eventually, that price is going to come down. So while we're talking about a lot of this stuff, you don't have to manufacture this stuff. You can just get stuff off the shelf. But if you know a little teeny bit, you could massively reduce the cost and start a consulting firm. I mean, if you were so motivated, right? And because nobody knows, or very few people have the ability to do this. And certainly the people that do aren't thinking about applications. They're thinking about selling it to other manufacturers and stuff. So just so you understand that.
So you had a question?
What would be the range on something like this?
So it's dictated by the rules. You can go way further than the rules let you go. So line of sight.
FAA rules.
FAA rules. So line of sight is the rule of thumb. And so
Did you even, since we said it, you guys all know what the FAA is, right?
Oh yeah, right. Federal Aviation Administration.
So they're the ones that govern what you can and can't do in the air. So
At least that's what they say.
and we're going to go into all the specifics when we get to policy and all that sort of thing.
What kind of enforcement is there? Like, who's to say that it's out of my line of sight?
Great question.
Great
question.
And a lot of what we're going to deal with here, and they're alluding to it, is it's really it's very muddy water.
It's quicksand.
So it's really all about your own internal morals and just kind of knowing what the laws say and how we can safely operate within those. So the reality is, if we were to go fly that right now and go fly it way out of line of sight, are we going to get in trouble? And I would say 99% no. But there's still a possibility that something were to happen, and then blah blah blah, cause the fire, and now it would come back to us. So it's all going to come back to us being responsible and users of this, knowing what the FAA currently, whether we agree with it or don't agree with some of their rules and regulations, we're all putting those in place, and that's what this class is going to teach you too. And hoping that if you go out on your own, you'll abide by those. And in the future, as the rules and regulations change, there's no question that these things are going to change. And so we're going to change with them and go from there. But again, right now, is there anyone that's going to come and catch you? No, not really. The reality is you're going to be more educated than the people who are supposedly going to be catching you are. It's the reality of it. The FAA doesn't have people that they don't have a police agency. They're tasking local law enforcement to come and uphold these rules and regulations. But most local law enforcement, they have way too many more things going on than them to worry about your little airplane flying around.
So I'll give an example. So a colleague last week, a fellow faculty member came up to me and said, hey, it was her cousin or family friend or something. Hey, my cousin got a drone for Christmas. I said, oh, okay. And she said, is it legal to fly that? And I said, yeah, sure it is. We'll just fly in his backyard or something. And then she said, well, yeah. I mean, he's crashed it a few times. And I said, oh, yeah, that'll happen. So he crashed it, what, in his backyard? No, on neighbors' roofs. I said, well, probably should practice a little more before he maybe starts going to, doing something like that. And maybe just stay, in an open park where there's no trees or whatever. I said, is he going anywhere else? She goes, well, yeah, he flew out to the oil rigs. And I said, the oil rigs, you mean? And I started saying things. She said, no, in the channel, in the Santa Barbara channel.
Oh, God.
And I said, well, how do you know when you just told you that? No, I saw the video. And so, I said, well, so here's the deal. If you're in an airplane, it'd be illegal to fly around. If you're in a ship, it's illegal to get close to the oil rigs after 9/11. So certainly it's probably it's unadvisable for him to do that. One, two, that's an idiotic thing to do in any event because there's no reason to be there, right? And so did somebody arrest him? Is the answer? No. Did somebody know he was flying around? Probably not. So the problem is the technology gives us this incredible ability to do all this crazy stuff, cool stuff, crazy stuff, and the onus is on us to be responsible. So nobody's out there necessarily, like Todd's saying, policing those guys. But as we'll talk about next week, whatever, when I talk about our history, when a TGI Friday guy did an idiot thing and crashed into the face of this lady back east, that led to all kinds of stuff. When that idiot drunk guy flew his drone onto the White House property in Washington, D.C., that caused a whole nother expletive deleted storm, right? And so that needn't have happened, right? And we could have been adults, we could have been mature, we could have been going forward, but there's always going to be some Yahoo that wants to do something. So we have those rules in place. They're really not worried about you flying in your backyard, quite honestly. They're worried about these Yahoos flying out to the gosh darn oil rigs or flying over the 101. And so these rules, in my understanding, are primarily if we need them, right? So the goal is to not push them, right? We don't want to test those rules. And as much as we can operate, we do operate within all those. As much as we can not create a spectacle and not create a problem, it'll be better for everybody in the long run.
Yeah, so exactly what they're saying. I mean, what this comes down to is we're trying to promote an air of responsibility and safety. So you shouldn't be flying with no experience in places that you shouldn't be flying because it's illegal for anybody to be there in the first place. So I mean, there's a lot of this is common or not so common sense, and we're hoping that through this, you guys will get a good understanding of how to safely and effectively use these tools. Do you have a question, Rebecca?
I was just going to say that the line of sight doesn't apply to height, right? Is that correct?
So the height,
because the height.
In theory, it's line of sight.
yeah, line of sight.
So if you were just on the other side of that hill and that hill was 500 feet away, that would not be considered line of sight. So that would be considered violating the current FAA guidelines.
The height restriction.
The
height
actual-
restriction
there is a
still
height restriction.
applies,
It still applies.
You can't go over the height restriction even if you can still see it.
Is that okay? That's okay.
Yeah,
There's
it
a
still
height
applies.
restriction.
It does
Yeah.
still apply,
Oh, I see what you're saying. Yeah.
and that's 400 feet. But we'll get into all that. So with that, I'm trying not to blast you too much details. So long story short, with this guy, it's mapping airplane. It's got a camera on the bottom that snaps pictures at certain GPS locations, takes all these pictures, puts them together, and makes you a Google map kind of thing. Really cool stuff, and I'll touch on that in just a second. So this is another one. This is a commercially made fixed wing. So like this, I put this together with our group because we have been training on basic electronics, how to put stuff together, how to do a little bit of programming, how to do a little this, a little that, watch some YouTube videos, or print some stuff. Voila, we have a mapping airplane. That costs us about $12.50. This guy costs roughly about $4,000. So it's the same exact thing.
Yeah. Same capacity.
Same capacity,
Same
same
batteries.
quality, same batteries, same everything, $4,000. So this goes to show you how, with us being a small university and having our research team, we're basically able to pick up some basic skills and put that knowledge of commercially available stuff together and kind of make it all talk, and then make our platform which is equally effective. And so there's other more I shouldn't say sophisticated, because a lot of technology is getting to the point where military and civilian technology is getting pretty close. But the military uses one that's similar, and the National Oceanic and Atmospheric Administration uses one similar called the Puma, but it costs $100,000 for the base model with, what is it? No camera,
With
right?
no cameras
It's
or
like
things.
250,000 just for some crap. The camera honestly doesn't even work that good. So,
No. So yeah, the consumer technology, the public technology is catching up really fast to the point where they're not really able to compete with some of these in some cases.
Yeah, or in a lot of cases is superseding the military stuff. Not with like the data encryption, that kind of deal, but for the stabilization and the kind of stuff that would make it more useful to us and user friendly. In many cases, we've outpaced the military spec stuff.
So go ahead. So this is the Puma. This is what the National Oceanic and Atmospheric Administration flies. I don't see the one until the.
This is a company called AeroVironment. They have a headquarters in Simi, and we'll hopefully get a tour of their facility, and/or they'll come and talk to us in a few weeks.
I can bring in a Puma too.
Cool. Yeah. So the Puma, it's designed to be a field deployable resource. They originally developed it for the military to be, there's a unit of guys. They need to find out if there's bad guys over that hill. They put it together and throw it, and they can fly it, and they can get recon imagery. But it's also very useful in the maritime industry or in maritime enforcement because it can land in the water. So they're able to launch it from a vessel and land it in the water and then go recover it. So that makes it very versatile because you don't necessarily need a landing pad or a strip. So this is a little bit of what I was talking about with the maps. So I'm leaving my position here to go work for a company that makes this software, which makes these images. So this is the Cook Islands. Oh, sorry. This is the Cook Islands, and there's the semi-plover next to the Puma. I thought that was a pretty cool comparison. It was like, this is 1,200, that's 200,000. But so this is the Aquatic Island, and all these little dots here, those are places where images were taken. So these are different research sites that we had, and so every dot is the individual place where it took a picture. And what happens is while this is flying, this is a GPS unit on top. What it's doing is it's got a camera down below that you can't see, but
in the belly.
In the belly. And so when it's flying over its area, you say, okay, I'm interested in this square of this area, this farmland.
Each of those pictures that unique.
Yes.
Yes.
And so each one of these are sites, and they're really clustered, so you can't really get an appreciation for how what the size and what the kind of shape of it is. But most of these are kind of rectangles. And so what happens is you say, I want to survey this site, and then it calculates stuff, and it goes, okay, I need to take a picture here, 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 here. And then it flies it by itself after you get it in the air, and it takes that GPS coordinate and it puts it on the picture. So you have, a few hundred pictures with GPS coordinates associated with them. You throw them in the software, and this is a marina. And so we fly over the marina. This is probably roughly about 40 pictures. And it takes all those pictures and it goes, okay, which one lines up here? It's called photo stitching. So it does that, but it goes a step further. And actually, because of the way that these incredible minds with way crazier math skills than I'll ever be able to comprehend have developed, is a way to essentially take those flat images and then use each one of those pictures. So if you imagine, like, if this is your area, you have a picture here, 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 here. They're able to use those pictures as kind of like an eyeball. So the way your eyes work is you look at your thumb. You have two different pictures, one from each eye. And so you're able to triangulate how far away that thumb is, or object in general. So what it does is it turns every one of those pictures into an eye. And it's able to triangulate individual positions from each one. And then it makes a 3D model, just like a video game. Like, you can fly through a canyon and we can take pictures, 2D pictures, and then make a pretty accurate model of the contour of that valley.
We'll see some in a second.
And I'll show you some of the 3D models that we can actually actively manipulate. that I've developed or that I've made with this software that I developed. And so what this is a DSM, a digital surface model. So this is actually taking that 3D model that we generated and then it's associating a color with height. So your red is going to be your higher, whereas your green and your blues are going to be your lower. So that's really useful in environmental science research because you can see, okay, there was this slope or this height of a mountainside, and there was the rock slide. And now in the next one, we compare it. So it was here, and now it's here. And you can kind of calculate the changes in the environment over time. Likewise, we can also use this to detect, okay, is this dam starting to buckle? Is it starting to shift? Are we going to have a potential breach in it? Or are we going to have a potential mudslide in this hillside after all these rains come? So it's really useful for kind of detecting changes in the environment. And one of the things that this is showing here, but it's not actually a map of, this is a special camera that Todd was using. This is called an infrared camera, so it sees heat. And so what the benefit of having a camera like this, when you're flying over, say you want to look at the mountains over here, say you want to find if there's any animals there, you can fly over and make one of these maps with that camera, and then you'll see the animals pop up brightly because they're essentially, a warm spot amongst a bunch of cold stuff. And so they use that also in agriculture with different wavelengths. They use near IR to detect the health of crops. So you're able to kind of figure out, are these crops all alive? Are they dead? What's the percentages? Does it need more water here? Are there pests attacking this part? So it's really helpful in many different realms of the environment.
And I would just say that, again, this is a lot of stuff and it might seem a bit overwhelming in jazz. Don't worry about it. The point being that even just a couple years ago, if we wanted to make an image like this guy on the right, you would have had to calculate, well, we need a blah, 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 40% overlap of each photo. And I don't know if we get it or whatever, so let's shoot video. Let's continuous picture so we know we get it. That sucks up massive memory and takes up all this space. So the program that Paul used to figure out, the optimal picture clicking and all this and that, and to pilot the craft. So Paul and our students launched the craft, take off, and then kind of got it under, autonomous control, got it going good, and then had the computer go fly itself once we were sure there weren't any airplanes nearby or that kind of stuff or any danger. And then it does it, and then it comes back, and then when it goes to land, then they would take over and they would safely land it. But the point is, that stuff 5 years ago would have required 4 PhDs to figure out how. Now it's open source software. Now it's free or relatively cheap software. And every single month, there is additional capacity coming out. So all of this stuff is not crazy pie in the sky. It's all within your guys' realm. Some of it right now, like Paul's saying, might need a little teeny bit of working, but it's something every single person in this room can do. This is not, you need to spend 10 years in some engineering program to figure out how. It's basically, let's get something and mess around with it for a couple weeks and figure out how to make it work. So it's pretty cool.
Yeah, and the way I learned all this stuff is playing with it, honestly. There's plenty of tutorials online for all this stuff. And I know I'm trying to cover a lot of really detailed subjects. And like they're saying, this is not the fully definitive. We're going to go over this individually, but I'm just trying to give you a sense of what all this technology is capable of. There's just so many applications. It's endless. It's really endless. Next one. So this is, I'm going to switch gears here and talk a little bit less about the aerial stuff and start talking about some of the underwater stuff. So this is an underwater submarine. This is a remotely operated vehicle, ROV. So the submarines we call ROVs. That's just kind of the nomenclature that's been established. So UAVs, aircraft, ROVs, submarines. And so the ROVs, this is called an open ROV. So we're talking about this open source stuff. So this is a company that there basically was two guys. There was an engineering student and a business. He graduated from business school, moved to San Francisco with big dreams, and couldn't get a job. So there's basically these two guys who are roommates in a garage, and they both were divers. They like to explore, and they're like, hey, we really want to go in these caves, but there's a very good chance we're going to die if we go in there. And so they thought to themselves, well, we need to get a camera in there so we can go check it out and see if we can go in there without hurting ourselves. So they got together, they got a garage. They're like, okay, how can we do this? And they looked at a bunch of tutorials online, and they basically made this prototype submarine. And they went out, they used it, and it worked really well. They were able to kind of look at the caves before they went into them, and they said, man, why isn't this something that everybody can have? And they realized that, with the ocean, there's so much unexplored area in our ocean. And there's some statistic that I read that we know more about space than we know about our ocean because of how deep and how inaccessible a lot of the ocean is. And so they basically decided that they wanted to help bridge that gap by making submarines. And they wanted to make it open source so they can have a community that builds. So we have 4 of them back there. So we've been using these for about 2 years, and we actually do real research with these. We look at animals out at our research station at Santa Rosa Island, and we look at the marine protected areas, and we do, through the environmental science capstone projects, essentially study if the marine protected areas are working. So are there more fish in the protected area or less fish in the protected area? Is there more diversity or is there less diversity? So it's a very valuable tool because, well, we don't have a formal dive program, and we don't have.
We do.
Well, I mean, now we do. Now
we do. Yeah.
Then we did not.
Right.
Then we did not. And so this enabled us to get into a semi-inaccessible place and do this research. And as this progresses, we're going to be going deeper and deeper and deeper. And you can't dive past a certain point because of issues with our human body being squishy. Well, these aren't squishy; they can dive pretty deep. These guys can actually stay under the water for 3 to 4 hours and go almost twice as deep as we can as regular divers. So it does offer a lot of really awesome benefits, and we can put sensors on these. We can put water chemistry sensors. We can do a lot of the photogrammetry, the photo stitching that I was talking about. You can do 3D models with these as well. And I'll show you some more of that in just a second. But yeah, this is a really awesome technology. It's about $1,000. This is a little bit more sophisticated. So this is
Little teeny bit more.
This is a tiny bit more sophisticated. So this is actually an autonomous vehicle. So I was talking about all those different acronyms. So they call this a submaran. So that means sub mean under, maran being the syllable.
It's French for Moran.
Yeah, it's French for Moran. So essentially what they've done here is this is a autonomous surface vehicle. So it looks like a surfboard. It's got solar panels. It's electric, but it doesn't rely on electric power for the motors. What it relies on is the sail that actually is able to sail around the ocean autonomously just by using this wing sail. But if it's made for long-term deployment, so you put it out in the ocean. There's no pilot. It's collecting data, or it's looking for bad guys poaching or fishing illegally, or it's protecting our coasts from submarine threats. Whatever the mission, it has the ability that if the weather gets really rough, the waves are huge, it folds this sail down and it becomes a submarine, and it goes underwater, and it uses the electrical propulsion to basically navigate under the waves until it's safe.
Goes like 200 feet down to wait, kind of thing.
Or if there's bad guys coming or anybody coming and they don't tell it, hey, I'm your friendly, and give them the secret code to make it not do this, it will close its sail and run away. So it's really, really interesting and really awesome. It's a company called Ocean Arrow, and they're based out of San Diego, and hopefully they're going to be coming here and talking with us and kind of talking about the different capabilities of the platform.
Just because it's deceptive of the size of this, can you give us an idea of how big this is?
I have a video. I'll link you guys. They had it at our boating center a couple months ago. I'll send the video for you guys.
And there's different sizes too. The prototypes are basically from Sean to about me here, but they just got contracted to build one the size of this room. So they have various sizes and various capacities and payloads and basically missions.
And we can't afford one, but we're hoping that we might be able to get a loan of one of their first. They're going into commercial production at the end of this year, and we're hoping to get one of their first, kind of engineering test models that wouldn't be cutting edge, but would be cutting edge for us. So that would really help our illegal fishing and that project with the autonomous buoys. So we'll see more on that later.
So this is just another shot of it with the sail down. So there's actually many different versions, but this looks really cool. It's like a surfboard that you can sail or surf under the water with. This is another kind. This is an autonomous surface vehicle. So if you notice, this has these pontoons or these basically legs that look just like that. We're building something similar to this, which is going to essentially do environmental sampling. So it'll drop in a water chemistry probe, check what the salt levels are, some of the water chemistry, see what the amounts of plankton, that sort of thing, and then stay out there and do long-term sampling. So this is just one commercially available model. This is another really cool one. This is called a wave glider. So it looks like just a surfboard on the surface, but the way that this thing works is really ingenious. I'm not going to fully talk about the way that this works, but essentially it has a submarine component, and it has this guy with fins. And so what it does is it rides waves. So as waves come up, it has wings that go up, which pull it forward, and as it goes down, they switch down. So it actually uses the wave energy to move it.
It's like a ratchet.
Yeah, it's basically like a ratchet. So basically, it just harnesses the power of the waves to move itself. So this thing could be out there indefinitely, just cruising around. And I think one of their longest deployments has been over a year. And they've taken these from California all the way to Hawaii, and had no issues whatsoever. So they're actually using these for long-term, like kind of monitoring, seeing if there's, like I was saying, marine enforcement issues or long-term environmental monitoring as well out in the ocean.
So the movement is all free energy. You don't need the solar panels. Solar panels for the sensors and communication and stuff. It's pretty cool.
And these are all controlled by satellite, by the way. So that when they're on the surface, they have, the communications satellite, and there's some guy in San Jose that says, I want you to go here, and then it kind of does its own thing. So these are loosely controlled, so they're mostly autonomous. So this is a more commercial ROV. These things are kind of the workhorse of inspection industry. So these are the guys that go underneath boats, make sure there's no damage to the underside of boats. They inspect moorings where boats tie up, and these are they call them observation class. And so we're not going to probably have, well, those are actually observation class as well, but these are a little bit more robust, but these are also 10 times as expensive. So the average starting for these is about 10 grand. And these have cameras that you can see live, and they're able to put sensors, but they're exponentially expensive. So this leads to the current technology with the open source methods that we have. We can make things a lot more available to us with limited resources. So this is how big they get. They're absolutely huge sometimes. And this is a work class one. You could see how tall this guy is in relation to this vehicle. It's a massive,
It's like a minivan.
massive. That's yeah, it's huge. And so this is going to be more of your underwater resource exploration kind of stuff, like your gas, your oil pipeline maintenance, putting down telecom lines or like internet lines on the ocean floor, and doing a lot more heavy kind of construction type work on the sea floor. And this can go really deep as well. It is absolutely crazy the scale that it goes into.
So that is not us, just to be
That is not
completely
us at
clear.
all.
But the skills you guys could pick up with us could absolutely translate to working for a company that might be able to afford this kind of stuff.
Yep, absolutely. So I'm going to kind of skip over the next few ones, but these are essentially underwater vehicles that will go down, do a mission, and then they'll come back up. So these oftentimes will save a lot of money. So Mbari, which is the Monterey Bay Aquarium Research Institute, they use these because they can send this unit out to Mexico from the Bay Area, and it could go collect the data and come back. And it costs them, well, they pay the initial, and then it's really just electricity at that point. If they have a research vessel with scientists, full crew, they're paying
Expensive.
hundreds of thousands of dollars. So this is a cost-saving mechanism. So they can throw it in the ocean, it does its thing, comes back. And there's a few other methods that they can do this. This is a propeller-based one, but there's in the next slide. This is a glider one, which actually uses the weight of water to kind of do an up and down gliding path. And instead of having a propeller, it fills up with water, gets heavy, falls down at an angle, blows all that water out, and then comes back up. So So it kind of
Like
does
this, right?
Yep, exactly. So it kind of makes this pattern. But yeah, so methods of conserving energy are really important, especially when you're underwater and you don't have the benefit of solar power. So this is kind of an overview of how the military is kind of using things. So these are surface vehicles up here, and so they're using them for port surveillance, for special operations, that sort of thing. So these are the ones that are going to go out and they're going to kind of take a look at weird situations that potentially have security implications. And some of them have countermeasures like electronic countermeasures like jammers and scramblers and that sort of thing. We don't worry about the scary stuff here, but that's how the military uses it. And these are not like attack ones, but I think that they do exist. So that's not our focus. Our focus is using these things for good.
Not trying to kill people.
Yes, exactly. So these are some of the 3D models that have been made using different platforms. And this comes to the whole photogrammetry thing where you stitch together the images. And this right here is actually a shipwreck that was done with one of these ROVs, the little ROVs. This isn't ours, but it's made with the same equipment. And this right here, this website, it's really cool. If you guys have some time, check it out. It's called Sketchfab. They have a lot of these 3D models that people upload where you can just kind of see what people are making from the environment. But there's also a lot of other things like video games, that sort of thing. But this is a really cool place to store models because you can have a place where you can see this, and it's got an interface where you can show people the 3D aspect of it. So this is actually a boat that sunk, and you can see all the different like ribs that are here. And this is from one of those ROVs, basically doing a lawnmower pattern with the camera facing down. It's a GoPro, and it just kind of goes back and forth, and it takes all those images, and they're able to create this 3D model from all those images. It's really cool because you can get a good perspective, and depending upon the quality of your camera, you can get really high detail in these models. And there's like so many applications. You can make video games with this. You can go into like a submarine canyon and map out the whole submarine canyon and make a video game out of it. But we're more interested in the science aspect of it, so we can find are these canyons being fed by certain sand sources? Are they at risk of collapsing? Can that affect trade routes, that sort of thing? There's lots of different applications.
Yeah, so you can think archaeological stuff, you can think art stuff, you can think clearly environmental science, you can think law enforcement. Has somebody stolen something, or is there an access point? There's just, I mean, it's amazing. It's amazing what we can do. Next one.
Yeah, go to the next one. And so the next one is actually pretty local here. This is the sea cliffs out in Santa Barbara. And so what we're really interested in, especially in environmental science, we have a professor who specializes in geomorphology, which is essentially the land and the way things move and or shift. And so this is a cliff face. And so with this 3D modeling technology, you can look straight down and you can see curvatures and you can see cutouts. So right here, you can see how right on this part, it kind of comes out, but on this part, it cuts in. So this means that we can look at this and look at how much vegetation there is and get a good idea, because the vegetation is like the anchor. But if it's cut in and there's not a whole lot of vegetation to keep that anchor, it's more likely it's going to fall. And so it can kind of help us predict if there were houses up here, are those houses at risk? And this is actually a pretty big thing in San Francisco, where they've actually closed down quite a few housing developments because the erosion is causing undercutting of the hill, and they're at very high risk of that entire housing complex falling off into the ocean. So this is really important stuff because we can kind of figure out, okay, is that coming? Conversely, after it happens, then we can look and say, okay, well, how much did fall down? And if that much fell down, how much is going to possibly fall down in the future?
And so just to be clear, nobody modeled anything here. These are just photographs.
These are all pictures.
That's been stitched together. And after these two-dimensional photographs have gone through this program, the program creates the three-dimensionality and then re-stretches the photographs on top of that.
Yep.
So there was nobody spending hours doing crazy mathematics stuff.
What you guys, sorry, question, go ahead.
I was just gonna wonder how accurate it is.
So I was going to speak to that. So the what you guys are looking at is the visual representation of that. But there's data that's behind the scenes here, so you can actually quantify some of this stuff as well. You can measure how tall is that cliff face,
Yep.
how wide is it, how much dirt. I mean, there's ways of actually doing volumetric measurements as well. That it's a little more complex, but there's data behind the scenes here that you can actually work with.
And that's, yeah, so like what he's saying, you can measure what the volume of this rock is here, the boulder. And so that's actually going to be integrated in the future into GIS intermediate. So that's going to be using the software to do those measurements, measure how tall the trees are, measure how much sand has eroded off the beach, all that sort of thing. That's going to be kind of incorporated into the intermediate GIS class in the future. And that's also how I'm going to kind of remain in a advisory capacity with the university. I'm leaving for the company that does this. When you pick up the phone to call tech support for the software, I'm the guy that answers.
Hey, Paul, where's the ethanol?
Sean, this is my business line. You can't call me at work.
So-
the model that Paul actually made.
Yeah, this is something that I actually made. So this is real life. This isn't something that could be. This is something we did.
And so just to be clear, this is just a first trial, right? So to answer Patrick's question, how accurate can it be? It can be more accurate, right? We can spend more time, fly more stuff. This is just like a GoPro camera, a off-the-shelf camera. The capacity that we're adding on in about a month is to add LiDAR onto this. That's more like a millimeter-ish accuracy. And so when we create models with that and then overlay the photographs, we can survey bird nests. We could probably do bird chick counts. We could probably do egg counts from, who knows, like 400 feet away or something, right?
Maybe not that far, but close.
I'm going to say probably 1,000 feet away. That's how it'll be. But the point is, everybody is worried about this technology. As it gets better, those concerns, maybe we don't want the endangered species to get scared. Maybe we don't want the neighbors to get spooked, but yet the city really wants to know, is that hillside eroding? Every few months, we have a better capacity, so we can be farther away without disturbing someone or bothering people or causing a safety concern, and getting killer data like this and providing useful data to folks that need to make important decisions that currently don't have that or would have to pay $1 gazillion million to get that level of data.
Yeah, this just you guys know time-wise that map probably, I don't know, was it one mission or two missions?
This is one mission actually.
Yeah, so it was one flight, like less than 15 minutes, and that's your results.
Yep.
I mean, granted, there's some behind-the-scenes work you got to do, but
Yeah.
the
Right.
actual
Data
aircraft in the
collection.
air, that's 15 minutes worth of work.
Right.
That's what you got.
Right.
I mean, like he's saying, there is behind the scenes work. I mean, the computer does all the heavy lifting for you, though. You just say, okay, here's what I got, here's where it is, and tick over. And then you edit the stuff later to kind of like manicure it towards higher quality. But it's really, as far as like person hours, I probably spent about an hour on it. It's okay. So I'm going to stop talking now because I've been talking for way too long. I'm going to show a few videos about rather showing some of the work that we've done. So the first one is the oil spill video. So we had the Refugio oil spill. So there's all that oil that came into the water. One thing that wasn't really being looked at is the sea floor.
Let me do a quick time check. So it's noon. We're going to keep going. If you guys absolutely have to run somewhere, you guys, it's cool. I'll send these links out, but we're going to go another 15 minutes, and then I want to do safety training. So if you guys have to bail or whatever, that's cool. But just so you guys know, if you have a noontime thing.
Yeah, these videos, I can put them up online too, if you guys want to watch them.
They are. They're.
Yeah, these are YouTube links. So,
All right.
yeah, so if you want to.
So sorry, keep going. Keep
Oh yeah, so the Refugio oil spill. So nobody was really looking at the ocean floor. So that's something we were curious about. And so what we did is we went out with Santa Barbara Channel Keeper, which is an NGO that essentially, it's an NGO that's essentially tasked themselves with protecting the Santa Barbara Channel. And so we went out with them on their research vessel and we dropped the ROVs and we essentially did surveys of the ocean floor kind of downstream for where the oil would have essentially come down with the current to see if there was any deposition of oil. And so this is just an example of how our research is affecting the environment that we live in. This was potentially something that they didn't even look at or consider. So luckily we didn't find anything. But this is kind of what it looks like when we're doing field research. Hey guys, these guys back here are the researchers. These are all of our UAV and ROV technicians. So guys, this is a video of ocean floor oil spill survey that we did, looking for oil deposition after the oil spill in Santa Barbara.
So the context to this, we can talk more in depth, but the context was people said there was no oil deposition after the Refugio oil spill last May, but there was no data given out, no nothing. We wanted to go in. Todd was patrolling the border. We weren't allowed to go in, and so the argument was if we can just put down, well, we could put down a diver and say if it's yay or nay. In this case, we could actually look to see if we didn't think there would be a lot of oil, but just to confirm there isn't. But this is recording it, right? So regardless of what you see, or regardless of what the whoever guy sees, this is a record, right? So if we see no oil, it's proof of no oil. If we see oil, it's proof. So in addition, so the one thing that's a bit better than a diver in this case is this creates a permanent record, right? High resolution record that we didn't see any oil. But if we did, right, that would be evidence. And just like we didn't see oil, that's evidence as well. So additional capacity that we otherwise didn't have.
Well, the other major point of that is you're not actually putting a diver in a situation, let's say that it was oil and something else that was
Right,
bad,
radiation or something.
Yeah, that's it. All this technology, it just takes a lot of the human risk element out of these situations. And then, as you can tell, like the camera is really close. We're getting a really good inspection of this kelp down here on the ocean floor. So a lot of times, if you go down there with the diver and say, I don't think so, but we have a record of it. So it's definitive proof that there wasn't any down there. Luckily.
Yay.
This is some of the fluorescent coral research we did in the Cook Islands. So this is actually where we took those ROVs and we put, working with a... Here we are at the Cook Islands. This aerial aquatic robot research came along. So this is guy Trimby. He's a master's student, and his master's project was to develop this sensor package to detect fluorescent corals. So essentially, it's these LED lights that shine down, and it's got a special filter, so you don't see anything else except for light that is reflected by these corals within a certain wavelength. And it's useful because we were actually able to realize that we can detect new species, not only of corals, but of other organisms that have these fluorescents, the biofluorescence, which is hypothesized to be a method of communication or warning. And we're also able to see some disease that's present in these corals. And so we put this package on it, and we went out to the Cook Islands, and we surveyed a lot of these coral reefs. And so this is from a GoPro that's one of the snorkelers has that's following it. But on the actual GoPro, which we'll switch to in a second, you'll see some of the coral light up right there.
So that bright spot.
That bright spot right there, that's coral that's fluorescing. But this is from outside perspective. In a second, you'll see where it's all dark, and that's from the filtered view. So this is the site that we identified. We went out there during the day. We marked our site, and then we went around. We cataloged all the different species that were there. And then later at nighttime, we went back, and we had a glow stick so we could find it. And then we surveyed it to see if we can identify this coral later. And so you'll see kind of the way it looks. So that's the glow stick up in the top left. And that's how we identified our site. And then we'll turn off the lights, and then you'll see these bright green corals kind of pop up. And so why these are also important is because the molecules that cause that fluorescence, you can use that in biomedical applications like detecting cancerous tumors. You can actually attach those molecules to the antibodies and go find different kinds of cancers or neurodegenerative diseases as well. So it's really cool stuff. And so one other thing that we found while we were out there is a species of clam that fluoresces. And this was not previously discovered before. So this is a Tridacna maxima, and it's so gorgeous. You have all these colors that you don't see with your naked eye because it has the special UV light and it has special filters. And so in the daytime, these are pretty, but they're just amazing under these fluorescent package. And then lastly, this is kind of a fun video. This is us in the Cook Islands, and this is using all the different platforms that we had. So this is not necessarily focusing on the research exactly, but it outlines that the work that we do with the research team here, that we go out to exotic places and we use this technology in crazy harsh conditions. There's no, Walmart that you can go and buy spare parts. You're out there in places where you need to know to use these systems, but also how to repair them a little bit, which is why the research team is here, because they go a little bit beyond just the operation. They go on the repair and the upgrade and the mission-specific side. And so this video kind of goes over the aerial mapping that we did. So you'll see some of the images of that, and you'll see just.
I'm Chris.
You'll see that some of the gorgeous images that you're able to capture with these. And this is just pure video. So this is just looking around one of the new islands that was newly formed in the Cook Islands, and you can see the quality of this and how you could use this for a promotional video. This is like marketing stuff right here. This is just so amazing. But also, you can get under the water and you can survey ecosystems, and you can look at fish populations, all kinds of animal populations. And in addition to all that, you can throw sensors on them, so you can look at the environment that these organisms are in addition to what organisms and how many. And so this is when we're doing some of the agricultural research. We had all the villagers that would come, and they basically crowd around us, and they'd just be so interested in what we're doing. And it is really awesome because we made a lot of really great friends, and that's the nature of traveling to really remote places with this stuff. People like on these islands have never seen technology like this, and they're looking at you like, wow, how do you guys even do this? And it's such an amazing experience. And in this picture, this is kind of awesome. But you run into situations where ideal circumstances aren't always there, and sometimes you have to make a field goal when you're trying to land an aircraft.
That was an aborted landing.
Yeah.
No.
That was definitely an aborted landing. It was really windy, and the aircraft was actually being attacked by birds. I actually had birds swarming around it while I was trying to land it. So I was trying to escape them while trying to land in heavy winds. But so you can see that there's just so many applications to all this technology, and we just really can't touch on it in this one lecture. And I'm really glad that you guys are in this class, because you're going to learn not only the safe and effective methods, but really what all the applications are to these different systems.
Cool. Well, we'll let this video trail off. I'll send you guys links to all these if you're curious, if you want to look at them again. And whenever we show stuff in class, I'll link to, I'll make sure everybody has those things for reference and things like that. So we're all good. So that's all we're really going to cover today. I think I want to take a quick 5-minute break. And if you guys could come up and type in your information in the sheet. If you have to take off, I'll just send it to you in Google Sheets form to fill out. And in about 10 minutes, we'll come back and we'll do our safety training. So if you guys haven't had lab safety training, we'll do that. And so we'll take care of it.
Mine's on there, but yeah, call any of us, Sean,